we have here another example problem. One dog barking is 92 decibels. I have 3 dogs, and they all start barking when we walk by another dog. Assuming their barks are the same intensity, what decibel level do I hear? So what sound intensity level do I hear? Now the actual decibel from the sound intensity level, or decibels, I hear from any one dog is going to depend upon how close they are to me. It's going to depend upon the dog themselves. But just to simplify things here, we're just going to say they have the same intensity. And since they're close to me when I walk, then that intensity, that sound level is going to be high. And yes, these are my dogs, which it's really obnoxious to try to walk all 3 of them at the same time. Anyway, since we are given a decibel level, that's our beta. And this is beta for one dog individually. For 3 dogs, we cannot So 3 dogs are not 3 times beta, meaning 3 times 92 decibels. That's not true. And that's because the decibels is the logarithmic scale, the sound intensity level. What is true, 3 dogs, the intensity of all 3 is going to be 3 times the intensity of 1. This is true because the intensity in watts per meter squared is the actual energy and how that is spreading over some given area. So what we need to do first is figure out the intensity of one dog. Then we multiply it by 3 to account for all 3 dogs and throw it back into our equation that relates sound intensity level to intensity I. My computer has a bit of a lag right now, so I'm going ahead and putting in the threshold of hearing because it's always 10 to the negative 12. So let's first find I1, meaning the intensity of one dog in 1 watt per meter squared. So I would put in my 92 decibels. And we're looking for I. This will be specifically I1. I need to divide by the 10 decibels first. So I'll have 9.2 is equal to the log of the intensity we're looking for over 10 to the negative 12. This is when I can take both sides, 10 to the 9.2 power. 10 to the log is going to give me I1 over 10 to the negative 12. So the intensity of one dog is going to be 10 to the 9.2 times 10 to the negative 12, which is the same thing as 10 to the, 2.8. No, sorry, negative 2.8. So when we're multiplying these quantities together, both of them are 10s to different powers. We can just add those powers together. Okay. We want to know the decibels that I hear when all 3 are barking, assuming that all 3 are barking individually with this intensity. So all 3 dogs, I'm using the same equation again, but this time I know the intensity. I'm putting in 3 times 10 to the negative 2.8. So 10 to the negative 2.8 times 3 divided by the threshold of hearing, log of that, multiply it by 10. So I'm getting 96.77. We have 2 sig figs based off of the numbers given. So I would be hearing 97 decibels instead of 92. Nowhere near 3 times the decibel level, of course. But it is louder, it is more intense to hear all 3 bark at once as opposed to 1. Now, realistically, they don't all individually have the same intensity. They're different sized dogs. They're going to have different intensity of barks. But this is just giving us an example on a simplified scale of how to account for 4 multiple sounds at the same time.